Now let's take a look at what's happening with the actual terrain in this scenario. And what I'll do for that is go to the 3D world view. Now you may or may not have a 3D world view with your package, it depends. But what I'm going to do in this particular version, this is really helpful to show you what's happening in 3D. And what I need to do is change the platform scale, and I'm going to give it line of sight, scale. And what I'll do is also turn on these beams. Alright, this airport radar is in the way. And rotating this around, we'll take a look. Okay, the straight flush is really in the way too. Alright. From here, however, you can see that there are red and green lines. Move this map over a little bit. Now the red lines indicate that there is no line of sight, and green lines indicate that there is a line of sight. So looking from the ASR platform or the straight flush truck right here, you can see that there is a line of sight between the airport radars, the other air defense systems, and this one, but not between the straight flush truck and the B1B. And it looks like the straight flush truck is high enough, so we should have no problem when the B1B comes around the corner. And I'm going to go ahead and take a look at what the B1B is seeing at this time. And he sees nothing, which is correct. Okay, so let me also go ahead and zoom in here. And while this is going on, since you can notice that he actually, oop, I forgot something. B1B, we want him not to be autopilot. He was saved as autopilot, so I'll autopilot, auto-navigate by time. And now the B1B will actually try and go back and try and make these waypoints. But he's already in this location, so what I'm going to do is I'm going to go ahead and stop and play him again. Let's make sure that autopilot, auto-navigate by time is on. So now he will try and make these waypoints as closely as possible. And what we're also going to do is let's add an attenuation region. That is a region of weather of some kind. So I'm going to go ahead and draw the attenuation region and go to the properties just like everything else. I'm going to give it a floor. Let's say it's a rainstorm of some kind. I'm going to give it a floor of, say, 20,000. And I'm going to rotate it around to, say, 15 degrees. And I also need an attenuation table for this. So let's say that this is going to be a moderate rainfall. Now these values in here are the attenuation per nautical mile versus the frequency. So that's all set up. And what I'm going to do is I'm going to get ahead and move that rainstorm right into the way. So obviously it will affect some frequencies more than others. I'm going to go to 3D world view, and now you can see the attenuation region is there, and you can see it only covers that altitude. So actually for most of these, in fact all of them, this attenuation region really wouldn't have any effect because it's high up. So what I'll do is I'll just go ahead and move it so it's all the way to the ground. Okay, there we go. Now you can see that it's actually covering the entire ground. So anybody in that region will then experience attenuation from their location to the edge of the attenuation region. All right, and we can see that the B1B is attempting to follow his pattern. And I'm going to do a signal analysis here. And I want to wait for him, so what I'm going to do is I'm going to go ahead and speed up the scenario a little bit. Now you notice that he didn't make that. The B1B did not actually make this waypoint, or he is making the waypoint, but he may not make this one because his turn and speed were such that he couldn't actually just make this sharp turn. But he is doing his best to get to the next waypoint, and realizes he's not going to make it, is going to bypass it and go for the following one. Alright. Now you can actually see that the radar, the straight flush, with several modes have changed, and they've picked up the B1B. And okay, actually what's happened here is that the B1B has lost, is below the mountainside here, so that now that the straight flush can't actually pick him up, so it's gone on to look for somebody else. And we can see that here in this view by looking at our line of sight values. And you can see that now this is red. These yellow indications, by the way, are just a check on passing through the attenuation region. So that part, looks like see, he's going in and out of that. He's sometimes green, sometimes red. That's because he's passing close to line of sight. And the straight flush is back on him, which is good. Okay, I'm just going to pause the scenario at this point and get back to what we're actually doing all this for. A lot of the time, or in many cases, what we want to do is we want to take all this data in the scenario and we want to send it to some sort of simulated devices where we can actually use it for training or mission rehearsal. Now I've already set up a series of simulated devices, and we'll just go over to that tab. This is actually the mission rehearsal system, the MRS. And what I'm going to do is I'm going to go ahead and select an own ship, which can be any platform in the scenario. There is no designated own ship other than what you select. Basically, when you're selecting it, you're saying, this is where I want to get my data stream from. So let's go to the B1B, and you'll notice that all these values, all the aircraft values themselves, are actually coming from the EWSS, and all it's doing is polling it, saying, okay, what is your angle? What are your 6 degree of freedom values? And it uses those values to go ahead and to set the simulated devices. All right, we'll go back to playing this scenario, and I'm going to turn on some of these devices, and I'll get more into the MRS system in a minute, but I'm going to go ahead and start up. And so you can see from the B1B's point of view, actually everything's quite active. And the B1B is going along. These modes are changing. Actually, you'll see a mode change coming up here momentarily because I think he's about to leave one of the ranges. I'll zoom out a little bit so you can take a look at that. In fact, let me turn off all this and we'll make it clear as to what's going on here. There's actually two emitters active. That's why you see two beams with sector scans. Okay, now he's just changed modes because he's left a certain range, and now he's back to just this one search radar. Alright, so let's turn everything that's back on. Let's go ahead and stop the scenario and take it from the top, and you'll be able to see what's going on from the device point of view. Alright, so we're running now, and I'll start again here. Every time you stop the scenario, you actually reset all your devices. Alright, so you can see the B1B is moving along, and he's about to reach a waypoint. When he reaches that waypoint, he'll start turning and making adjustments to altitude, speed, etc. And that will be reflected in the devices of the MRS. Let's see, where is he? He's almost there. Once again, everybody's gone back to following their rules. Okay, B1B is coming up on his turn. And if you watch these devices, you'll see all of them start to kick in as changes are made to the motion model. Now, another important part here is that with the right devices, you can set this up to actually control that platform rather than just watch it run in the EWSS. So, for example, if you had a throttle control or a joystick, you could run this. You could actually fly this B1B according to the parameters that have been set up, and you could tell it to just go ahead and ignore the track and fly it like you would an airplane.